Welcome to AI Verdict. In this explainer, we're going to cut through all the noise and give you a really clear, actionable verdict on what the AI engineering stack for 2026 actually looks like. So let's just dive right in.
So if you're trying to become an AI engineer right now, you're probably feeling, well, totally swamped, right? I mean, there's a new framework or platform dropping every single week. You've got LangChain, vLLM, Pinecone. The list just goes on and on. If you're sitting there wondering where to even begin, trust me, you are definitely not alone.
But here's the thing, here's the verdict. You do not need to learn everything. That's the trap. The real key is learning the right things in the right order, and most importantly, understanding how all these pieces actually fit together to build real working applications. Okay, so before we start throwing a bunch of tools at you, let's take a step back. We first have to define the role itself. What does it actually mean to be an AI engineer in 2026? Because, believe me, the role has changed a lot. See, in 2026, being an AI engineer isn't about training these massive foundational models from scratch. Nope, that's really the world of ML research. Instead, your job is to be a system builder. You're the one who designs, deploys, evaluates, and operates reliable, production-grade applications that use these powerful models. So the most important thing to have is a mental model, a framework for thinking about this. And the best way to do that is to have your tool stack map directly to the lifecycle of building an application. We're going to use this exact framework. We'll start with building and orchestrating the logic and go all the way through to observing and iterating on it once it's live.
All right, let's get into it. First up is the core stack. These are the foundational tools you'll use to actually build your apps, connect them to the outside world, and get them running. Okay, category 1, building and orchestration. LangChain is still the best place to start, period. It's where you'll learn the core ideas, things like prompt templates and runnables. But once you're ready to build for production, you need to graduate to LangGraph. This is for building durable, stateful agents that can handle things like loops and checkpointing. And here's a pro tip. Even if you don't use it, go study the OpenAI SDK. It's a masterclass in clean agent architecture, especially in how it handles things like tool definitions and calling multiple functions at once. Now for a category that a lot of beginners just skip right over, connectivity. The Model Context Protocol, or MCP, is all about standardizing how your apps connect to data and tools. And look, in a real enterprise job, understanding concepts from MCP like least privilege, which is just a fancy way of saying you only give an agent the exact tools it needs for a task and nothing more, that's what's going to separate you from the pack. It's the difference between a hobbyist and a pro. Okay, so in 2026, just calling a model API isn't going to cut it. You have to understand both sides of the coin when it comes to running models. On one side, you've got managed platforms like Fireworks AI, which are fantastic for getting up and running quickly and tuning open source models. But on the other side, you've got self-hosted infrastructure. This is what you need when you're after deep optimization and total control. You need to be comfortable with both. All right, let's dig a little deeper into self-hosting. vLLM is pretty much the standard for serving open source LLMs. With vLLM, you have to understand things like KV caching, which is really just a smart way to speed up generation by reusing calculations. Then, for really high-performance pipelines, you need to know about NVIDIA Triton and its features like dynamic batching, which is basically just grouping requests together to be more efficient. And finally, there's Bento ML, which brings that real production discipline, making it way easier to package and serve your models. Okay. We've nailed down the core. Now we're moving into what I like to call the professional's toolkit. This is the stuff that truly separates the pros from the hobbyists. It's all about making your systems robust, reliable, and actually understandable. So, retrieval augmented generation, or RAG, is absolutely everywhere. So what's the verdict? You need to learn one database integrated option and one dedicated vector database. PG Vector is the super pragmatic choice if your team is already using Postgres, but for dedicated options, Weaviate is amazing for its open source hybrid search, while Pinecone is kind of the gold standard for a managed at-scale solution. Now, listen up, because this is where almost everyone gets RAG wrong. They get obsessed with the vector database itself, but the real secret sauce, the thing that actually stops hallucinations, is mastering what happens before you ever hit that database. It's all about how you chunk your documents, how you configure your retrieval strategy, and how you use hybrid search to pull back the most relevant context possible. That's the game changer. I really want this next part to sink in. This is the category that separates people who build cool demos from people who build professional, reliable systems. Evaluation isn't a nice to have. It's a core, non-negotiable part of the job. You should think of evaluation as continuous integration, or CI, but for AI behavior. You need a whole suite of tools to do this right. Langsmith is incredible for building your test datasets right from real user traces. Ragus is super focused on RAG quality metrics. Is the answer faithful to the source? Is it relevant? TrueLens lets you get really granular, letting you score, say, your retrieval steps separately from the final answer. And MLOflow brings that mature classic ML discipline, like versioning, to the GenAI world.
Sooner or later, things are going to break in production. They always do. And when they do, you have to know why. That's observability. When a user gets a totally bizarre, hallucinated answer, you need to be able to trace the entire journey of that request from start to finish. OpenTelemetry is your foundation for that. Then, OpenInference adds specific details for LLMs, helping you debug things like tool misuse. And on top of all that, platforms like Galileo or Phoenix give you these powerful debugging layers and reliability guardrails.
Okay, let's pull it all together. We've walked through the entire lifecycle, from the first line of code to monitoring and production. So here it is, a rapid-fire recap of your definitive AI engineering stack for 2026.
So here's the AI verdict stack. You build with LangChain and LangGraph. You connect securely with MCP. You run your models with Fireworks AI, vLLM, or Triton. You retrieve context with Weavier or PG Vector. You evaluate everything with Ragus and Langsmith. And you observe it all with OpenTelemetry and OpenInference. That's it. That's the stack.
So there you have it. The stack isn't some big mystery anymore. It's a clear set of choices mapped to a logical life cycle. So the only real question left is, what are you going to build with it first?